What's up, everyone? It is trig time one more time with Miss Wesley. We had been working in radians and kind of converting between radians and degrees in the previous lesson, and now I want to bring it all together. I want to bring it all together and do some exact value practice as well. So we're going to pick it up. Where am I at? I'm on the bottom of page 21 of the Trig Packet for starters. I'm looking at a unit circle that you may already have filled in, and I had a joke. It was, why didn't the orange win the race? I don't know. He just ran out of juice. Let's look at something equally as fun. Okay, so when you filled this in, how did it go? Can you check your answers with mine? I love splitting up the unit circle in fractions in terms of pi. So what I mean by that is you have 0 radians, you have pi radians all the way on the other side, 180 degrees. So half pi, pi, 3/2 pi down at 270. So what are other important ways to split this thing up? We should split it up. Okay, so 30 degrees is pi over 6 of a radian, right? Double that, 60 degrees is going to be pi over 3, and 45 degrees is what I left out in the middle. Keep it going. What'd you get for 2 pi over 3? Did you get 120? Here 135. Here I'm back to just measuring in radians of 5 pi over 6, whether you convert or just count over, 1/6, 2/6, 3/6 pi, 4/6 pi, 5/6 pi, right? You have a whole pi. 210, what was it? Go past it, so 7 pi over 6. 225 should have got something like, pi plus another quarter, so 5 pi over 4. And then 240 is a 4 pi over 3. Down at 270, quadrant 4, we'll see a lot of these angles today. So what are we at? 300 is 5 pi over 3. 315 is 7 pi over 4, almost to 2 pi. And then 330 was 11 pi over 6. Get used to these values. They're your friends. We've worked with a lot of them in degrees. Let's see if we can do the same thing with radians. Do not be scared by a page like 22 of the Trig Packet, because you know what? I'm going to use the same techniques I used in degrees, just convert to radians now. I like to think of quadrant 1 of the unit circle if I see a bunch of exact value exercises presented in front of me. So while this was 30, 45, and 60, can we put it in radians now and make it pi over 6, pi over 4 radians, and pi over 3? Just so we don't have to draw the whole unit circle, we could get a quadrant 1 set of exact values. So just like 30 degrees had the coordinates, what, the x in this little triangle would be longer than the y. So square root of 3 over 2 coming first, a 1/2 going second. And everything's over 2. And we're counting down on the x's. Square root of 3, square root of 2, square root of 1 for the x's. 1, square root of 2, square root of 3 for the y's, like that. That's going to really help with the whole page. If we need help with signs of some of our answers here, no big deal. We can use the acronym ASTC to figure out what's positive where. ASTC. And if anything quadrantal comes up and if I need it, here just think in radians instead of degrees. So we've got 0 radians, pi over 2, and then pi, 3 pi over 2, back to 2 pi. And we've got the important coordinates there, the x's and the y's around the unit circle, so we can get the signs and the cosine. So 1, 0 we've used, 0, 1, this is awesome review, -1, 0, and 0, -1. I think we're set up. We have our little trig toolbox here, and we can easily just check this out and get the sine of pi over 3. It's just like me asking you to get the sine of what is pi over 3, 60 degrees, same deal. But I don't want you to have to feel like you have to convert all of these to degrees to be able to solve them. You've got this visual here, right? Pi over 3, sine is the y on the unit circle. It's going to be square root of 3 over 2. All right, one down. Tangent of pi over 4. Think about 45 degrees or pi over 4 here. Put the y over the x. The same thing over itself. It's kind of silly that I even write this out when I know one fraction, the same fraction over itself, is going to give you a tangent of 1. Secant of pi over 6, right? It's like me saying, what's 1 over the cosine of pi over 6? And we know pi over 6 has 30 degrees. So 1 over, go to pi over 6, think of the cosine. You're coming out further than you're going up, the x, and you're going to put 1 over the square root of 3 over 2. That'll flip it, right? 2 over square root of 3 unrationalized, And with a rationalized denominator, that could be a good expression for 16. So this is not new material. This is more practice with the same old stuff we've been looking at already, but in a different type of angle measure. Cosecant of pi over 2, this is quadrantal, right? 1 over the sine of pi over 2, where 90 degrees falls. Use the y, so 1 over 1 gives you a value of 1. You have to admit, this is kind of fun. Let's look at tangent of 5 pi over 3. Okay, for these going down the page, 18 and the rest of them become really important because now we have that added step. We're out of quadrant 1 and we're not quadrantal. We need a what? We need a reference angle. So can you figure out, give me a quadrant where 5 pi over 3 would fall. So if we count in thirds pi, here's 1/3 pi, 2/3 pi, 3/3 pi, 4/3 pi, and 5 pi over 3 is going to be down in quadrant 4. Okay, you're going to love reference angles with radians. If this is 5 pi over 3, do you know what gets me back to a full 2 pi, a full 6 pi over 3? I have 1 pi over 3 left over. One thing I love a lot of things about radians. That's what you'll learn about me. But one thing I really love is that it's easy to get reference angles for these. Look in the denominator. Your choices for special angles in quadrant 1 are good choices would be a pi over 3 reference angle. We would know that's 60 degrees and we know its exact values. Pi over 4 would be a good one, and pi over 6 would be another good one. Well, you know what? Look at the denominator. If the denominator says 3 there, you can trust the reference angle is going to be pi over 3. It's just a little bit easier to visually pick out the reference angle from the bunch. Now, there were other things I had to think about, right? I'm down in quadrant 4, so I got to check my sign. So A, S, T, C, only cosine and secant are positive in quadrant 4. So let's make this equal to negative the tangent of its quadrant 1 reference angle, pi over 3. Okay, aka 60 degrees, so negative the tangent of pi over 3, you're putting the y over the x, and pi over 3 is the angle where you're going up higher. The y is the bigger number. So put square root of 3 over 2 divided by a half. And we can simplify and just keep that answer negative. 2's canceling, you get negative square root of 3. Right? Great practice for us. And now we're working in radians. Okay, let's look at 5 pi over 4. Can you guess its reference angle just by looking at it from the conversation we just had? I'm going to guess, since it says over 4, it's got to be some sort of pi over 4 or 45-degree reference angle. And I still think it would be wise to try this one the same way and draw an angle of 5 pi over 4, figure out what quadrant we're working with here before we get going so we know if this answer needs to be negative. Count with me quarter pies, right? 1/4, 2/4 pi, 3/4 pi, 4/4 pi, 5 pi over 4 is going to land you in quadrant 3. So A, S, T, only tangent and its reciprocal are positive there. Let's find this value and make it negative. So it'll equal negative sine of pi over 4. That's just like 45 degrees. If I look up to my diagram, I get negative square root of 2 over 2. Cool. 5 pi over 6, and it's a tangent again. I can guess the reference angle just because it's so easy with radians that it's going to be pi over 6. I kind of neglected to show that here in the picture. You're 1/4 pi past pi in that picture. Let's check this one out. Where would 5 pi over 6 fall? Well, you're not quite all the way over to pi. You're 1/6 pi shy of that. So you're in quadrant 2 over here. And how much pi would get you back to a full pi here? If you've gone 5 pi over 6, you need 1 more pi over 6 to make that happen. Okay, but AS, tangent shouldn't be positive there. Let's keep it negative. Now we're working with pi over 6, which is just 30 degrees, where the y is only going to be a half, and the x that we divide by is going to be square root of 3 over 2. So we can call this one negative 1 over square root of 3, and we would always prefer a rationalized denominator, negative square root of 3 over 3. Cosine of 3 pi, we're back to something quadrantal. Where is 3 pi on this circle? We'll count full pies. It's a semicircle, so 0, 1 pi, 2 pi, 3 pi. We're over here. So it's the same as saying, what is the cosine of pi? That is coterminal if we subtract 2 pi from that original angle. Think of your unit circle and think of the x value, because the cosine should be the x there. And we'll say negative 1. Okay, ooh, secant of pi, pi again. Well, you know what? We just got the cosine of pi to be negative 1. Let's flip it, right? Reciprocal of negative 1, still negative 1, gives you that answer. All right, I'm loving these. What about 23? Sine of negative 8 pi over 3. Well, one nice thing about it is that the denominator lets me guess the reference angle, right? The reference angle is going to be pi over 3 because that is your original reduced denominator. And we'd be almost completely good to go here because we know the sine of pi over 3, but we still have to decide whether or not this answer needs to be negative. We should see where negative 8 pi over 3 falls. Can you work with me clockwise now? Let's count around in thirds pi. So 1/3 pi in the negative direction, negative 2/3 pi, 3/3 pi, 4, 5, 6, 7, 8. Negative 8/3 pi. Man, we've gone all the way around once, twirled back again to quadrant 3, AST. And just something to think about when you are dealing with an angle measure like this that's pretty low negative and you'd like to be able to think about it more concretely, remember that number 1, you can add or subtract any integer multiple of 2 pi to this and you have the same angle. So what I mean is, if I was blanking on where this would fall, I'm allowed to add 2 pi to it. That's like adding 6 pi over 3, and now I'm down to negative 2 pi over 3. This is a little bit more concrete for me to see that I've just gone 2/3 pi of the way in the negative direction. You also can convert this to degrees. Feel free to do that too. You get something like negative 120 degrees. Okay, well, I guess we've established if we're calling this a quadrant 3 angle, this answer should be negative. Think of the sine of pi over 3. You're up higher than you are out horizontally. Let's go negative square root of 3 over 2. Okay, 2 more. Cotangent, oh my goodness, same angle, negative 2 pi over 3. Well, that is in quadrant 3. You're going 2 pi over 3 this way. Your reference angle is very conveniently having that same exact denominator, pi over 3, will get you the full way back to that side. So this equals the cotangent of pi over 3. You see those denominators matching up. Should there be a negative sign out front? Well, AST, tangent and its reciprocal, cotangent, are positive in quadrant 3. Let's keep this one positive. And let's put the y over the x for pi over 3. And actually, x over the y, right? Cotangent is the reciprocal. So x over y gives me 1/2 for pi over 3 as its x value over square root of 3 over 2. And you get 1 over the square root of 3, which rationalizes square root of 3 over 3. Cool. All right, last one, negative pi over 6. This one doesn't look too bad. What quadrant are we in? You're just going pi over 6 in the clockwise direction here. And what's cool is it's what I just said for the reference angle. How far do we travel? We traveled pi over 6. Do I need a negative sign? ASTC doesn't look like it. Cosine stays positive in that quadrant, the x value for pi over 6. And we'll just finish it off with a square root of 3 over 2. All right, it has been my distinct pleasure to work on trig with you, and I hope that you have a terrific rest of your day. See ya.